I wanted to talk about today was the first thing is this one size fits all, doesn't fit anyone topic. And really the key takeaway here is that with cloud computing in particular, it really opens up the opportunity to build lots of different solutions. So you don't have to use a relational database. In the old days, I think starting 1970, they came up with a first, relational database design, and then since then, it's really been used for almost everything. And in fact, even if you look at the early 2000s, this is when the web frameworks were a big deal. Like, there was Ruby on Rails and Django and all these, and all of them are essentially making a relational database easier to work with. Excuse me. And so really the idea here is that you don't need to do things like always use an object relational mapper, which is a way of taking Python code and converting it to a relational database. Instead, there's lots of different ways to use databases. And on AWS, they do have support for relational databases. They have Aurora, RDS. They also have support for key value databases like DynamoDB. In DynamoDB, the interesting thing about this is that if you're mostly working with, let's say, user profile data, it really is a better fit than a relational database because it allows you to map more closely what you're doing. The relational database, the issues with it are that because it is a transactional based system, it's not going to be available when it's writing data, right? So if you're writing the data, it's going to lock the system up and you're not going to be able to access that data. And it causes really availability issues. Also, likewise, if you're dealing with graph databases or a graph relationship like social networks, for example, a graph database is a much better solution. And in fact, let me just show you real quick here. There is a, if I go to Neo4j, let's go here, Neo. So the Neo4j website is really a good example of how you could play around with graph databases. And if you scroll down here, you can see here there's a link to try it now. And you can launch a sandbox. And the sandbox I'll just log in here with Google. It'll allow me to go through a bunch of different scenarios that they've set up for me and really highlight some of the powerful things that happen with graph databases. So let's go. Here we go. This is one of my favorite ones: is Russian Twitter trolls. And what it does is it's going to fire up this environment, and it has a bunch of real data from when all the stuff was happening with the election. And what's interesting is that some of the questions that you would ask are going to be very different when you have a graph database than a relational database, because you can start to determine really these network effects here of what's happening. So I'm gonna just show you real quick here how this would work. So you go inside of here, and you can start playing around with this. And again, you could do this yourself. I won't go through all of it, but basically you can look through these different scenarios, and you can see how it will let you it'll let you kind of explore this data set here by walking through a few different examples. And they explain the data model. You've got a tweet, a user, a troll, a hashtag, source. And then also you can model the relationships. So instead of doing, again, like relational database type mappings, you can map this relationship. And there's also a language that you can deal with. And I think you can just copy this and it will go through and let you run it. And then you can see here, this is show us the number of followers with greater than 1,000 count. Right, and so that would be a cipher query, and then here's another one. You could go through and you could see all the different relationships in this database. You can see the kind of people who the trolls are interacting with. Anyway, later, and this is pretty funny. Thanks, Obama. So they're using social media to spread polarization and discontent, and you can use the graph database to more easily make intuitions about a social network-based relation. So if you have some time, definitely recommend going through and playing around with these. It costs nothing, and it's super informative. So that's graph database. Next up here is we have in-memory databases. In-memory databases, what's powerful about those is that they are really designed for microsecond latency, key-based queries. So when would you use this? So one example would be if you were going to build a recommendation engine and you had a very expensive algorithm that calculated who should follow who. You don't want to run that all the time because it maybe would be very it would be very expensive in terms of computational resources. So instead, you could run it once a day and then put that into a cache somewhere and then just retrieve the information. Versus if you're using, let's say, a document database, you're constantly hitting the document database because it's so quick. But in terms of a very expensive algorithm, like a lot of times collaborative filtering is what recommendation engines are typically built on top of. It's a very, very expensive algorithm. Next up, you have indexing and searching log files. So this is a totally different kind of pattern, and you would use a search engine for that. So let's say you put data inside of AWS and you wanted to build a search interface for it. In the old days, again, lots of people use relational database for this, and it just hammered the database because it's not really a perfect fit for that. But there are specific services that are designed for that. So that's really one of the takeaways, is that if you're using cloud computing, is use the right tool for the job. Don't just because you're familiar with a relational database, use a relational database, or use the right tool for the right job. And I've found, in fact, that many profile-related problems work very well with a key value database, and it's simpler. It's much simpler to work with. And again, if you're doing network analysis, social network theory, the graph database is really a powerful solution. If you need to get very quick access to counts, maybe you're doing data warehousing, then you want to have the same number served out to a lot of people. Why would you hit the database every time if it's going to be the same result all day long? Just put it into a cache somewhere. Likewise, if you're building a search engine out of your database, why are you doing that? Why don't you just put it into a search engine? And a service like Elasticsearch can do that. So that's just high-level theory here. Now, I also wanted to get into this Vocarium a bit here. And with Vocarium, I believe everyone has access to this now. And what I'm going to do is I'm just going to walk through a few of these labs here. So I'm going to log out and just log into an account that I can run these. So what I was going to do is actually go through, let's see if I can get through querying data in Athena, and then also querying data in Amazon S3 with Athena. And let me, before I do that, just describe why this is an important concept to think about. So if I go here into Sketch.io, and then I maybe take this out here, the main concept here is that most data pipelines are going to look something like what we're about to do in a real world production environment. Let's go through here and let's draw this out here. Is that you have your data lake like this, and then inside of the data lake, you're going to have to pull first of all, you're going to have to put the data inside, and then you're going to need to transform the data and put that somewhere. So let's say that this is maybe this is a Postgres database, right? So we'll just call this Postgres, and maybe even this database doesn't even live in Amazon. So how are you going to get it into Amazon's S3 storage system and then do something with it and then query it? Well, one way you could do that is, and this is again what we'll get into it, is you could use something called AWS Glue. And what AWS Glue will do is it will index this for you, and then it will create basically a catalog, and then this catalog can be used by another system. And so this catalog essentially tells, let's say that there's 1 terabyte of information that gets put into it. We grab it out of Postgres, we put it into S3, and then we have a listing here of everything that's inside of there. Well, this could in fact be a ton of information. Let me just, yeah, we are recording this. This could be a ton of information, and then how do we query it now? So if it gets to a large enough size, or maybe it's a petabyte, how do I actually query this efficiently? You don't want to just pull a petabyte of data out of S3, look inside of it, then put it back in again. That would be incredibly expensive. Instead, you want to index it. And that's what the Glue system does, which we'll get into. The Glue system can index it, and then we need another system to query it. And you could potentially figure out a way to put into a relational database or something like that, but an easier way, or a search engine. But there's a system that Amazon has called Athena that works in conjunction with Glue, and you can feed Athena this catalog, and then what happens is you can just do SQL queries against the metadata, and then it will pull out the records when it needs to pull out that data. So what this is a true big data pipeline. And what's nice about it is that the stuff we're about to go through, you could go into a Fortune 500 company, and with just essentially a few clicks of a button, replace maybe what 100 people do. And I think this is one of the issues right now, is that a lot of times the reason why people are not successful is that they're doing a lot of work. And this is really a big theme here, is with the cloud, and I believe I mentioned this last week, is if you're doing a lot of work and you're writing a lot of code, you're doing something terribly wrong. And in general, you should do almost nothing, because you use the tools that they've given you. And so that's kind of high level diagram here. So now let's go ahead and let's dig into this. So first up, what I'm going to do is I'm going to go to this query data in Athena with Amazon S3. I'm going to click on my work. And then what I'm going to do is I'm going to go through and run this lab. So you can see that we're going to use Glue, and a Glue is an automatic ETL system that's serverless. It integrates with Athena, Redshift, and also EMR. So Athena is a serverless data query tool. Redshift is a data warehouse, and then EMR is basically Spark or Hadoop. It's a MapReduce system. And so what we're going to do is we're going to use Glue. So make sure you understand how to do that. We're going to crawl some stuff, and then we're going to query it using Athena. So I'm going to go ahead and say start lab here, and that will take just a second to start it up. Yes, sure. Oh, okay. So let me fix this real quick. What I will do is I will. Good question. So what I can do here is I think I didn't publish them yet for you. So I'm going to go to Vocarium. And then I'm going to go to UNC here. I'm glad you asked me this. And I'm going to go to assignments. Let's go to data analytics and go to assignments. Go here, publish. That's why. I don't know why they do this. They hide these at first. So you now, very good question. There we go. So you should now get access to this. Is that correct? If you refresh, these should start appearing. There we go. Yeah, it should, or maybe log out and log back in again. I think it's instant. It should be instantaneous. But yeah, that would, okay, perfect. So people see it. Okay, great. So great question. And I'll publish the rest, the other ones later that we have access to. Great question. So now that that's there, next I'm going to click on AWS here, and what I'm going to do is probably just put these side by side. So I'm going to go like this so I can see this one, and then I'll put this one right next door so we can kind of look at both at the same time. Okay, so first step here is let's get in here. In this scenario, you're a data analyst working at a international development agency. We're figuring out some drought relief data, or this could be, coronavirus or whatever currently is happening in the world. You can see here at the diagram is that the IAM system has to make sure that the user has access to these resources, Glue, Athena, and S3. So the first thing we're going to do is we're going to crawl data inside of Glue. And so this is, again, what Glue is designed for. And I know many people that are doing data engineering in real companies, and this is actually one of their tools. It's a great tool. So first step, we're going to go to Glue. So I'm going to go here, type in Glue, and you can see here it's a fully managed ETL system. And next up, what we're going to do is we'll choose Get Started, and then we're going to add tables using a crawler. So add tables using a crawler, and then we're going to type in weather right here. And then the next step here is specify a crawler data source, and so we're going to click Data Stores. And what that means is that we can choose S3 as a data store, or I've actually used this before in consulting projects, JDBC, which you could point it to some external database that lives in the other side of the world, and you could periodically pull in that data and index it and transform it. So it's a very flexible and powerful system. Also could talk with Dynamo. We're going to leave it, I believe, at S3, and we're going to grab this NOAA data, which stands for some kind of scientific thing. I know somebody that works there. I don't know exactly the acronym. So we go here, next, and then we'll say no next here. Not sure why that's popping up, but let's see. Let's paste this in here. Next, add crawler. Maybe I have to make it bigger. It's something. Okay, yes. So I just have to make it a little bit bigger. Okay, so then I go back here and I say choose an existing role. So again, this is something they created for us just to simplify things, but if you were using this, you would need to make a role, make sure that your IAM role had the ability to talk to, for example, S3. And then we're going to go to next. And then we're going to select run on demand. So this is another really interesting component of Glue, is if you are doing this on a real project, probably to start with, you want to say run on demand so that you can just test it out. And basically what it's going to do is going to crawl something for you. Later, once you get the system working, then you would go and make it run at an hourly interval or a monthly interval or something like that. So we'll say next here. And then for the database, we're going to say add a database. And we're going to put in a name of a database, and we'll call this weather data. And essentially what this is doing is it's allowing us to have a catalog. And then we're going to scroll down here and we'll say next. And I believe that's all set up. We don't have to do anything else. Okay, so now it says run the crawler. So we're going to tell AWS Glue to run it now, and you'll see it. We'll say run it now. And basically it's going to go inside of S3 and it's going to look inside of that folder and it's going to find all the metadata about what's inside that folder. So if there's files in there that have data, it'll find the types, it'll find the names of the columns. And that's, again, the power of something like this is you could write all this code to do this yourself for sure. But why would you do that if you could just click a button and do the work of 50 people? And this is really the part of the cloud I think that is very disruptive is many organizations right now have tons of software developers recreating poorly what is already just a few button clicks of the cloud. So next up here we can say read. We can read more if you want to do that. We crawled that, said, okay, after 1 minute, it'll change to ready. And then we can refresh this. So the thing's still starting. And then we can actually, we'll see that a table has been created. So we'll just kind of let this thing go here for a second. Let's see. There we go. Maybe even I'll expand it a little bit. Status, 1 minute elapsed. Yeah, I think, there we go, stopping. So I think it created it. Okay, so now it created that information. And now what we're going to do is we're going to, you'll see the table added column, right? So, and what we're going to do, inspect the data AWS Glue captured. So if we click on this, I believe we can inspect it by going to the tables. No. Yeah, go to tables here. And then you can see like it figured out all this data, right? So it figured out, here's the name of the column, here's the data type. It even shows you like what kind of data is it. So pretty powerful system that automatically does something that you would have to write some Python code to do, for example. And so now we're going to go to databases. We're going to go to weather data, and we're going to choose tables and weather data. And I guess that's what I just looked at. And we see this. And you should see something similar to this, right? We have this. And now we're going to edit it. And again, this is another cool thing about this is you can edit the schema on the fly here. And so we're going to now tell it we want to clean up the data a little bit here. So we're going to, let's see here. So we want to change the columns by selecting them and entering new names. So we're going to choose edit schema here, and then we just change, we're going to change these. So I'll just scroll this over a little bit like this, and we'll say that's going to be called station. Oh, I guess I have to work hard here and actually type something. So station, and then next up would be date, and then type, observation. So this would be very similar to if you had, like, let's say an existing database and you had maybe columns that were a certain name, and then you were talking to another database you wanted to integrate. You could then change the name of their columns so that they would be the same name, so it would be easy to integrate the data. That might be one example. Let me see, am I messing this up here? So we got station, date, type, observation, imflag, and then we have sflag, and then we have qflag, and then the next one is time, like that. Okay, and we're going to say save, So we've now changed the schema so that it's got meaningful names here. And now we're going to query the data using the Glue catalog. So we're going to go to the tables icon here, and then we're going to click on this CSV, and then we're going to view the data. So from the action menu, is there a view data here? Where's this view data? View properties. Where am I missing this? So check the table box. Let me go back here. So check this. Oh, there we go. And go to view data. Preview the data. Okay, and then this will say get started. And what's cool about this is that you must specify a storage bucket to hold the results from the queries that we run. So we're going to go to S3 now. I'm going to open this up on another tab, and we're going to go to here, and I believe there's a bucket, yeah, right here. If I click on it, let's see, so in the bucket properties, there should be an ARN here. Let's see, select the bucket name, choose copy bucket ARN. Where's copy bucket ARN? I think I don't. Overview. Why am I messing? Or is it here? There we go. Copy bucket ARN. Okay, so now that I've got that, we're going to return to Athena, and we're going to do set up a query result location. So we'll go here, and we'll paste that in. And I believe if I do a Control A, I can just swap this out a little bit and just change this to S3 / Control A, and then do a backslash as well. And I don't think I need to, so yeah, you have to do this, swap that at the beginning, and I believe it should look, yeah, and then these aren't completed. So we'll go ahead and say save. And now what I can do is from the list of databases, we'll choose the weather data. So we got that, and then choose a table CSV. We got that. And then there's a little ellipsis here. And this is a little tricky to find. This allows us to query it, like create a default query. So we're going to click on this, and I believe we just say preview table. And then it creates a select statement for us. So again, pretty awesome is that if there was petabytes of data in here, like we have already cataloged, we have already indexed it, we know what's inside. Like, look, we can see this is all the preview data, and I can run this query, and it's going to show me all this data. So, and you can see here, this is the first 10 records of that table. So next step, what we're going to do is we're going to create a table for data after 1950. So we're going to create an S3 bucket to store the external data. The bucket should be in the same region. Follow the information. So I believe what we're going to do, copy the following query, paste it, remember to place your bucket. Okay, so let's go to S3 now, and let's create a bucket, and we'll call this bucket whatever today is, March 1 UNCC demo. This may not work for you because it's all bucket names are unique. Okay, so we got this. I'm going to click on it. I'm going to copy this bucket. Actually, I think I just need to copy this part of the name right here. Here we go. So now I'm going to go back to Athena, and I'm going to put this into a query. So I'm going to make a new query, and I'm going to paste this. First, I'm going to paste this in. So I'm going to put a SQL query in here. Whoops. So I'm going to copy this, paste it in here, and then take this bucket name. So it'll be, if you're doing the same thing, it would be whatever bucket you created. And then we're going to create a new table, and we're going to put the results of this into this bucket. which would be that for me. So we're going to say, here's the format of the data, here's our external location, and I missed an important part, the where clause, which is the one that actually finds us the date we're looking for. So basically, we're saying, just give me the data between 1950 and 2015, and then put it into this bucket that I created. So now that we've done that, I think we can say return, and I can say save. Wait, actually, this should just work here. Let's see here. I don't know why the run query is not working. Let's try. Let me do this. Let me just paste this in one more time here. Paste that in, and then I'll go back to the bucket name that I had, which is this one. And we'll paste this in here. Okay. And maybe I put format query. Is that what I have to do? Sure, I'll format the query. And then I believe I can just do a control enter to run the query. There we go. Control enter. And then it's going through this. It's going through all the data inside of the original S3 bucket, filtering based on our query, and then it's going to put the results, I believe, into that other bucket. So let's let this thing crank here. So again, you can imagine the complexity. You're working with petabytes of data, and someone hires you. They're, oh, look, you're a graduate of a data science program. Let's have you, query this data. I think many people would reach for Python first, right? You go through and hey, let's just start playing around with some Python code. You could be at it for months trying to figure out how to get this done, versus if you use the right tool for the job, step one, index it. Step two, cook it up to a serverless query system like Athena. So behind the scenes here, it's spinning up servers, doing all kinds of stuff, and then running the SQL query. And then you can use the skills you already have, just write some SQL statements, and then go through and filter that data. So we can see here that it was successful. And now look, I can click on this, and I can say preview table. And then we can look inside of our table here, and you can see all this data that it was able to get from that time period. And I think if I go back to S3 now and I refresh this, that you can see that it put, actually this is a pretty big data set. Wow. How big is this data set? If I go back into S3 here that we're querying, this unsaved here, those don't look that big, but I guess because this is just the metadata, but the real in this scenario, we copied the real data to here, and I think if I went to properties, it should tell us. Well, anyway, we can see here these are big files. These are our Parquet files, so like compressed data files here, but. Now we have the ability. We create easier ways to partition the data and then query it. So next up here, we're going to run a query from the selected data. So we're going to put this in here. So we're going to say go through here and run another query against the table that we just created, this late 20th. Again, we'll say control enter to run it. Query was successful. And then we can also go to the view that we set up here into the data, and then go through here and say preview. And then this will show us that result. So you can essentially treat this gigantic data lake as a database. and use big data tools to query the data. And you can see a fairly straightforward process to do this. Now let's go ahead and let's run another query here, and let's select some.
It looks like your Orbi voice is not registered. For help, go to the Netgear Orbi app.
Let's run this select, do control. And so this is going to select the year by average, and we can see what this thing does. There we go. So in a nutshell here, I believe this shows how powerful it is to use an AWS S3 data lake as essentially a big data warehouse without needing to do anything else, without needing to put it into some other system like let's say a Redshift database, or put it into some other system. And again, this allows you to really like run circles around people that are just being very inefficient. This took just a little bit of time and allowed us to query the data. Now, what I'm going to do is I'll just stop this recording, because I think this was a good demo here, and then we can maybe shift to something else. Let's see. So I'm going to go here, and I'm going to stop. Here we go.